Alright guys, this is lesson 3.1, and so the beginning of chapter 3. And so far the first two chapters, a lot of what we've done has been things you've seen before, which has been kind of a nice way to start trigonometry. Chapter 3 are going to be topics that you have never seen before. And so this is a really good time to kind of really focus in and pay attention to what we're doing here. And so we're going to start lesson 3.1. It starts with something called radian measure. And this is going to be a new way to measure angles. And if you think about it, there's lots of ways, when you take other measurements, there's different ways you can measure things. If you measure length, you can use feet, you can use inches, you can use a metric system, you can use centimeters or meters. And when you're measuring weight, you can use pounds, you can use kilograms, you can use milligrams, you can use ounces. So there's different units to measure quantities. And so for angles, it's the same thing. We've learned degrees, and now we're going to learn about these radians. Okay. Why would you want to learn a different way to measure angles? Well, degrees are very useful for doing triangles. So anytime you're solving a triangle, you're going to use degrees. And you'll switch your mode on your calculator to degree mode. Most of the physics applications, if you're in physics, those also involve degrees. Other applications, such as latitude and longitude, those are measured in degrees. So degrees have lots of good reasons to use degrees. And so now we get to these radians, like, well, why would we want to use radians? And it turns out there's going to be two reasons. The second reason I'm going to give you in chapter 4 when we get to it, we get to graphing and you realize, oh, it makes the graphs come out much nicer. But the reason I'll talk about right now is if you take more math, and kind of the math that comes typically after trigonometry is calculus, when you learn certain formulas in calculus called derivative formulas or integral formulas for your trig functions, for sines, cosines, tangents, it turns out if you use radians, your formulas come out much, much nicer and simpler. And so when you take higher mathematics, it's just going to be assumed that you are using radians. If you notice your graphing calculators, the default setting was radians, and we had to switch those over to degrees when we were doing the first couple chapters. And now if we move into radians, we'll have to switch that back to radians. Okay, so we'll keep that for right now. And like I say, there's a better reason, or another reason in chapter 4 we'll also give for why you don't use radians. But what is a radian? Well, first of all, what is a degree? Well, we knew we took a rotation, and we broke that up into 360 pieces. And so 1/360th of a rotation was a degree. So what is a radian? Well, a radian is going to be an angle, and it's going to equal the length of the radius of a circle. And we'll just kind of sketch this out right now, and then in class we'll certainly build on this quite a bit more. So just think of this roughly. Here's a circle. Just work with me. Pretend that's a circle. And let's find the center. And this distance right here we'll call the radius. So what is a radian? Well, what you do is you peel off this radius, this length. You start on the positive x-axis again, and you kind of bend the length of one radius on your circle. So that looks like about the length of a radius. And so you get this angle that started on the positive x-axis. And again, as we follow it, trace our radius up here, about that much. We'll do it more precisely in class. That angle right there is 1 radian. So hopefully the first thing you notice is, wait a minute, a radian is a heck of a lot bigger than a degree. It's not going to take 360 radians to get around a circle. If you think about laying a radius on here, here's one radius, here'd be the next, here'd be the next. You can start to think, okay, it's not going to take too many radii to get around a circle. All right, so that's the definition. Like I say, in class we're going to build on that more and kind of give you that physical where you actually measure these out and get a sense for a radius or a radian. But for right now, we're just going to leave it at that. All right, so the big question is, oops, and I wish I could hide this, but my screen shade is hidden too. So we'll just work with this. So the big question is, how many radians are there in a circle? And again, we can trace this out in class. We'll do this in class tomorrow and try to act surprised when we get the result in class tomorrow. But how many radians are in a circle? Well, we know the circumference of a circle. So formula for circumference. Circumference. I'll get that. All right. So circumference of a circle is 2 times pi times the radius. But guys, the radius, we just defined that radius is equal to 1 radian. So if we solve this, or if we take our circumference, take our circumference, divide it up into radii, spelling's not going so good tonight, what is left? 2 pi. So we took our circle, we broke it up into radii, 1, 2, 3, 4, 5, 6, and a little bit more. Ignore that one right there. And what did we get? We found out there's 2 pi, and 2 pi is about 6.28, roughly speaking. So it turns out there's about 6.28, or there are exactly 2 pi radians in a circle. So a pretty big angle is 1 radian. In fact, it only takes a little more than 6 of these to get around the whole circle. And again, why would that be? Well, look, right here. Circumference, break it up by the radii, and what's left right there? The 2 pi. So we get this conversion factor, which is very important. 2 pi radians, otherwise known as approximately 6.28, is the same as 360 degrees. Divide both sides by 2, and we'll get a reduced conversion factor, which we will use very, very frequently. Pi radians, so 3.14 radians, and it goes forever, I know, but approximately 3.14 radians is 180 degrees. All right, let's try this a little bit, see if we can convert back and forth between degrees and radians. So now, what if I gave you a 45-degree angle? How many radians would that be? Well, we have our fact here. Pi radians is 180 degrees. So let's use our conversion factor. These are degrees, so it's 45 over 1. Let's multiply by pi radians per 180 degrees. Notice the degree unit is going to cancel out. Oops, didn't leave my 180. Sorry about that. Now, the degree radian is going to cancel out. The degree unit is going to cancel out. And we get 45 pi over 180. We can reduce this fraction by 45s. And so I'm going to get 1 pi, and 180 divided by 45 is 4. So 1 pi over 4, or we get pi fourths radians. And again, keeping in mind, pi is a little bit bigger than 3. We get about 3/4 of a radian. And with your intuition, you say, oh, that kind of makes sense. 45 degrees is about 3/4 of 1 radian. So 45 degrees is pi fourths radians. Let's try it again. 60 degrees. Same conversion factor. Pi over 180 degrees. Oh, look at that. I got to remember that degree unit. The degree unit cancels out. And I get 60 pi over 180. Reduced by 60s. And I get pi thirds. And pi is just a little more than 3, so I get just 3 over 3, or about 1, slightly more than 1 radian. So 60 degrees is a little bit bigger than 1 radian. All right, some of these come out very nicely. The first two, 1 and 2, those came out very nicely. They don't always come out so nice. Let's try 249.8 degrees. And again, we'll just learn some conventions here as we do this. 249.8 degrees, conversion factor doesn't change, so multiply by pi over 180 degrees. Units cancel out, and I get 249.8 pi over 180. All right, the first two had fractions that reduced very nicely. Remember how nicely that reduced? That was a fourth. This reduced. That was a third. This fraction is not going to reduce nicely. Plus, they had a decimal in there to begin with. And so the convention is going to be, when your fraction reduces nicely, leave pi in your answer. So 1/4 pi, or pi fourths, 1/3 pi, or pi thirds. When your fraction does not reduce nicely, that's going to be a mess, then multiply pi into your answer and just give a numerical answer without the pi in here. And I got to pull up the calculator quick, and let's get this one. All right, the calculator will show up in a second. and we'll get this answer. I'll show you what I'm talking about. And it's not consistent, but it's just the rule that we use in trig when it comes out nicely. There's half the calculator. There's a full calculator for you. Oops, and I covered up the problem. So let's go 249.8. And it's times pi, so I got pi right here, divided by 180. And I get this answer, so 4.359, we'll just round it, 4.36 radians. And the pi, as you'll notice, let me just save that actually, as you'll notice, the pi is actually already multiplied into this. And that's A-OK. Let me put that somewhere. That's not blocking too much. So I get 4.36 radians. So I've already included the pi in that answer. All right, same thing for the 132. It's not going to reduce real nicely. So 132 times pi over 180. I could reduce the fraction a little bit. But unless it's something really good, like a fourth or a third, you could multiply this out. So 132 pi over 180. And let's figure this out. Bring out the calculator. So 132 pi divided by 180. What do we get? 2.30 radians, with the pi already included in there. So 2.30 radians. The other convention is radians do not need a unit. So if you give a number that has no unit on it, and you're measuring angles, it's assumed that we were using radians. If you meant degrees, then look, you should have labeled degrees. So degrees get a label, radians do not need a label. All right, that's our first part. You can kind of think through what the next parts are going to be. We took degrees to radians, so could you take radians back to degrees? You can, and that is coming up in the next part.